Hello grade 6, here we are at lesson 118. We are moving back to the textbook. We are finished our geometry unit, so you can put that behind you. Now we're going to be working with numbers from here on out and no more shapes. So lesson 118 is going to be about ratios and equal ratios. So first we have to look at what is a ratio, and a ratio is just the math word for a comparison of two quantities or amounts. And I'm going to be using this little picture here of these dots to help us understand what a ratio is. So a ratio is really just a way to show a comparison. So what we have here are 4 orange dots and 2 blue dots. So I could show the comparison between those two amounts by saying I have 4 orange dots to 2 blue dots. That is a ratio, and that's one of 3 ways to show a ratio. You could just say I have 4 orange dots to 2 blue ones. Or you may also see a ratio shown like this with a colon in the middle. It means the exact same thing. Or there's a third way, and this may be the way that you're the most comfortable working with for ratios, because you can show a ratio as a fraction, and we've done lots of practicing with fractions, so that should be a familiar way to you to show a ratio. So all 3 of these mean the same thing. They are all the same ratio, 4 orange dots to 2 blue dots. So for that one, we were comparing 2 different types of dots, or part to part. Okay, but the second one that we're going to look at is you can also use ratios to show part to whole. And this is what that means. So now, instead of comparing orange dots to blue dots, I'm going to choose one of the colors. So I'm going to choose my orange dots, and I can say I have 4 orange dots to 6 total dots. Okay, so now instead of comparing my 2 colors, I'm comparing one part to the whole amount. And just like with the other one, you can show that in your 3 ways. And for this one, the fraction probably makes even more sense, right? You could think I have 4 out of 6. 4 of the dots are orange out of 6 total. But it works the exact same way. You're just comparing something slightly different. Now the next thing that we need to look at is equivalent ratios, and equivalent, just like with fractions, means equal ratios. Okay, so you may come across questions that look kind of like the example I have here, which gives you some information. So it says 6 out of 10 people wear glasses. So if we express that as a ratio, we can do it as a fraction, 6 out of 10. Okay, so 6 people to 10 people. They wear glasses. In a group of 50 people, how many could you expect to wear glasses? And what we're going to do here is we're going to set up an equivalent ratio, which should look like an equivalent fraction, something that you have seen before. Okay, so the 10 is representing the total number of people in the first ratio. So what I'm going to do is I'm going to put the total number of people from our second number here on the bottom as well. So we've got the total number of people on the bottom. Now we need to find out what is the missing number at the top. So if 6 out of 10 people wear glasses, and now you have a group of 50, how many could you expect to wear glasses? And this works like an equivalent fraction. When we did equivalent fractions, you thought to yourself to take that denominator and turn it into a 50. What was being done to the 10? Well, it's being multiplied by 5. So all you have to do to find the missing number at the top here is do the same thing. Multiply by 5. Let's see if I can erase my question mark here. And you end up with 30 people wearing glasses out of 50. So the exact same thing as equivalent fractions, equivalent ratios. So hopefully that's not too tricky for you. Now, there's one other cool thing that we need to learn about ratios today, and it is another way to show if ratios are equal, or you can think of it as equivalent fractions. So we already know for this first one, I used the same example, that 6/10 is equal to 30 over 50. But I'm going to show you a different way that you could have come up to that answer. So cross product is when you are taking the numbers that are across from each other diagonally, and we're going to work with them. So I'll highlight them in different colors. So a way that you can tell that a ratio is equivalent is if you take the numbers that are diagonally across from each other and multiply them. So I'll start with 10 times 30, the yellow line. 10 times 30 equals 300. Now I'll take the blue line. 6 times 50 also equals 300. So if you take the numbers that are diagonally across from each other and you multiply them together and you get the same answer, your ratio is equivalent. Now for this first example, it's pretty easy to see, right, that you would just multiply by 5 to get your equivalent fraction. But for this second example here, it's not so easy to see, right? You can't multiply 4 by a whole number to get a 6. You can't multiply 8 by a whole number to get a 12. But these are actually equivalent ratios, and we can use cross products to show that. So I'm just going to highlight them again. You can think to yourself, 8 times 6 gets us a 48. 4 times 12 also gets us a 48. So since those answers are the same, you know that those are equivalent. All right,